is the vacuum state as a squeeze state, and we must show that delta x1 whole square is less than 1 over 4 and delta x2 whole square is less than 1 over 4. So this is the condition for the squeeze state. So similarly, we can take delta x1 whole square, which is equal to x1 square average and x1 whole square. And now this is a vacuum state. So we must take the average of the vacuum state, 0 and 0, and putting the value of x1 square. x1, which is equal to square, so we can get this, and this is equal to this. And now I can expand the a plus a dagger whole square, then we can get a square, a dagger square plus a dagger plus a dagger a. And now the first term, which is equal to 0, but how? You can see that I can write this a square a in this form. So this is remains the same. And now if we apply A on the vacuum state, the annihilation, there is no any photon, then it means that how you can say that this can be equal to, it means that when annihilation operator is applied on the vacuum state, so then must be equal to 0 because there is no any photon. So it must directly goes to 0. So it means that if we apply this on this, so it is equal to 0 and there is no need and you can get 0. But whenever if you apply a dagger on a vacuum state, then you can get 1. Matlab one photon can be created by the creation operator. So now why this is equal to 0? Because if I take this 0, a dagger, and 0. First apply a dagger on this, then we can get a dagger and this must be equal to 1. And if we apply a dagger further, then it gives us 0 and 2. So it means that 0 and 2 are orthogonal state and this goes to 0. So this must goes to 0. And similarly, this term can be expanded like 1 plus a dagger a and a dagger a. And here, if I multiply this side with this, so we can get 0, 0 and 0 a dagger a and 0 a dagger a. So we can add these two. So 2, 0 a dagger, and this also equal to 0 because if we applied this a dagger a and the 0 state, so if this apply on the 0 state, it goes to 0. So it means that the whole term must be equal to 0. And from here we can get this is equal to 1. And from here we can get delta x1 square, which is equal to 1 over 4. And similarly we can apply this for a delta x2 square, but only the value of x2 is different and the value of x2 is equal to 1 over 2 iota a minus a dagger. And the same process we can apply and we can obtain delta x2 square, which is equal to 1 over 4. So the condition is not fulfilled and we can say that the vacuum state is not a squeeze state.